Hello and hope you're doing well. Welcome back to my channel. Today we are in day 27 for the Mastery LeetCode Challenge. We are almost about to complete this particular month. Till now we have not seen those hard level of questions. So probably this is the assumption that the last few days we are going to have some very difficult questions. And today also we are having a very good question, by the way. It's really something that you can try if you are somewhere decent in coding, then you can definitely try this. It's all about ideas. If you have those ideas, you can get this question. It's definitely not difficult one. So the question, let me zoom in, let us begin quickly. It is question 2780, minimum index for valid split. So first thing, as like the way I always say in my videos, please go through the question once, take the link from the description, go through it once, because see, this is something that you will have to teach yourself, how to interpret the question, how to understand, like how to extract the maximum out of the question. You'll have to do that part. So I cannot like read every word and try to explain, because you also know, I also know, that will not work out ultimately. I can teach you like the ideas, I can teach you the solutions part, but again I cannot go and teach you the English part here, like reading every word here. Okay, so again, in this question, the highlights are that basically you'll have to split the array in one particular position. Okay, let us say like you have to ultimately the answer is going to be the index in which you're going to split the array. So idea here is, after splitting, the whole array will be divided into two parts. Okay, the first subarray and the second subarray. Now there is something called as a dormant element. Okay, what is a dormant element? Some see, a subarray, or let make I am making this thing very generic. A subarray will have, I am calling it a subarray. Okay, I'm not calling it a array directly, because ultimately we'll have to apply this concept on subarray only. Okay, so a subarray will have a dominant element. Okay, if like you can say a particular element in a subarray is called dominant if more than half of the elements of the array is filled with that particular element. Okay, so that is the basic definition of a dominant. I will again repeat: the element x of an integer subarray, okay, of length m is dominant if more than half of the elements of that particular subarray have the value of x. So as simple as that. So idea here is, let me give you a very simple example here. For example, let us say this as the subarray. Okay, let's take this whole thing as a subarray. In that case, if you see the number 2, okay, is present three times, the total length is 4. Okay, out of 4, like see, a element will be dominant only if it is present more than half the number of elements present in that. Okay, so for example, in this case it is 4. What is the half of 4? Half of 4 is 2. So a element has to be present more than 2 times for it to be called dominant. It is present 3 times, so it is called dominant. Okay, that is the basic reason. It has to be present more than half. Okay, so I always take the length of the array divided by 2. So the element has to be the frequency of the element has to be greater than that to be called dominant. Okay, that is the basic idea. Now, what the question here is that you will have to return the minimum index such that the split that you are making, okay, both the arrays that are resulting have the same dominant element. Okay, I will again repeat: return the minimum index, okay, in such a way that the split that is being made, there are two subarrays getting created. In both subarrays, you will have the same dominant element. Okay, that is what the question is about. If that is not possible, I will return -1. Okay, so that is the question. And if you see, yeah, they're calling it as a zero index array. Okay, that is first thing. Yeah, then yeah, rest of the stuff are pretty clear. Only thing is you have to remember is that wherever you're splitting, okay, let's say you are splitting index number 2, that index number 2 will be part of the first split. Okay, that is something that you have to understand very cleanly. That if you are splitting at index I, then I will be part of the first array sub array. Okay, I will be part of the first sub array. From I+1 onwards, it will be part of the second sub array. Okay, that is what it has. And yeah, I guess pretty much I've covered everything. Yeah, both ends being inclusive. Okay, yeah. Yeah, so they've given the difference of value split also, that yeah, this thing and both have the same dominant element. So both things I've explained. To go through the question, it's almost pretty clear. Okay, then let's go to example number 1. Okay, now for example, what I will do is I will teach you through the output that I've generated, because that will make the things very clear. So I hope the screen is pretty clear to see. For the example, Maran, what I've done is, see, whenever see, first thing that you have to do is you will have to find a mechanism to find the dominant element. Okay, when I say the dominant element, I mean to say in the whole array, not just a subarray initially. In the whole array, you have to find the dominant element, because see, the idea here is, see, dominant element, what it means exactly. Dominant element means more than half of the array will be part of that. Okay, so that is why the idea here is, see, the way they have mentioned it. No, they are saying for both the splitted subarrays, you will have the same dominant element. So idea here is the dominant element for the whole array will also be dominant element for the two halves. Okay, as simple as that. That's something that you have to assume and you have to proceed with. Okay, now what I've done is, first you will have to find a mechanism to find the frequencies of each of the elements. Then among the frequency, you have to choose the dominant element. Okay, now once you have the dominant element, you will have, what you have to do is you have to go through the array again once. Then you will have to like see like which portion we can split, because see, they are asking about the minimum index. That means if the leftmost index we have to choose such that we can split. So what I've done is, whenever the dominant element is occurring, I am trying to see how much index, like what is the the ratio of the frequency of the dominant element and the total number of elements that we have in the left half. And similarly, the frequency of the dominant element and the number of elements we have in the right half. So I've done a frequency, like the ratio of that, and for each index I'm calculating that. So whenever this ratio is greater than, let's say the idea here is, the numerator And in order, if you compare, what should happen is the see, that's what they mentioned, right? It should be more than half. Okay, so what I can say is, maybe if this ratio, if you do, it should be coming greater than 0.5, only then it is considered as valid. So the idea is, whenever both the ratios together comes more than 0.5, then you can go and say that as index as the answer. Okay, so let us see here. In this case, you can clearly see 3 is the dominant element. Let's see for each index how it works. Okay, for index number 0, so it is 1 by 1, because there is only one element in the current. See, if you split it at this index, so only this single number will be there in the left half, and rest all will be there in the second half. Okay, so if you talk about this, the left half will have 1/1, that is the first element, that is the element in itself is the dominant element. But in this case, it will be 3 by 6. Okay, because see, this is the right subarray, so here 3 is the dominant element present 3 times, and the other 3 are again the other element, so it is 3 by 6. Okay, similarly for I equal to 1, it is 2 by 2 and 2 by 5. Okay, because if you see, this is the both elements are dominant. In this case, you see only two elements are dominant out of this. Okay, so it is 2 by 5. So in either of these cases, till now we have not seen a case where both the ratios are greater than 0.5. Okay, but yeah, yeah, in this case, actually nothing is the answer, so we are returning -1 in this case. But if you see some other cases, for example, the example number one. Okay, let's go to example number one. See, for I equal to 1. Okay, yeah, remember, only when the dominant element comes, we will start. So after I equal to 0, we are not doing that. Okay, only when the dominant element comes, we will do this part. Okay, for I equal to 1, as you can see, it is 1 by 2. Okay, that is, this is my left subarray. Okay, and this is my right subarray. So in this case, you see for the left half, only one element is dominant and the other element is non-dominant. So it is 1/2, and for the right half, it is 2/2. So in this case, if you see, it is 0.5. Okay, and it is 1. So in this case, it's not greater than 0.5. So it's not the answer. Okay, let's go to index. Yeah. Now if you go to index number 2. Okay, this is the the split. The highlighted elements will be part of the left subarray, and the single element will be part of the right subarray. In this case, if you see, it is 2 by 3 and it is 1 by 1. So in this case, basically in this particular division, we have both the I can say both the subarrays will now have a dominant element, because there is an element which is same in both the cases, but it is like the frequency of the element in each of the subarrays is greater than 0.5. Okay, I mean, like, it's present more than the half of the other elements. Okay, as simple as that. So this is going to be the answer. In the same case, we have seen example number 2 also. Here also, if you see, at index number 4, basically, that is, I'm talking about this 0, 1, 2, 3, 4. Okay, and this, yeah, this is going to be the division. Okay, in this case, if you see, there are 3 ones in the first half out of 5. Similarly, in the right half, there are again 3 ones again out of 5. Okay, so 3 by 5, 3 by 5, again the ratio is greater than 0.5. So at I equal 4, we are getting the answer. So 4 is going to be your answer that you have written. So yeah, that is all about this, and let us see how to code it. So as I mentioned, there are there are two steps before this. First step is how to find the frequency of each element. Second step is, based on the frequency, you have to find the most frequent element, that is the dominant element. Okay, and one more thing, important part is that it's clearly mentioned it has exactly one dominant element, so there will not be two dominant elements. Okay, see what you have to do. I'm showing you the hashmap approach. First of all, create a default dictionary. I'm going to each element and I'm recording the frequencies. This is the first step. Second step is that now I need to find which element has the highest frequency. Okay, so what I've done is, see, one more thing that you can do is, see, whenever a element, okay, and the frequency of element, okay, what you can do is, see, you can basically avoid this step. Okay, but how you can do that, I will tell you that. See, this is where the logic comes. See, if you see the exact definition of a dominant element, no, if you go through it exactly, they are saying it should be present more than half. Okay, so I know the length of the nums. Okay, I know the length of the nums. So what you can do, extra condition, is that when you are doing this experiment, after that, just add an extra if condition, that if the frequency has crossed the n by 2 mark, then that means we have got our like the dominant element already. So you don't have to do this part of the code. Basically, in this part of the code, what I'm doing is, I am taking like all the frequency values, among them which is the max I'm taking here, and then I'm just checking which number has this particular frequency, and because of that, I'm getting the most frequent element and the most frequent element frequency. Okay, these two things I'm getting. But again, this is not the right way of, like, this is not the optimal way of doing it. I'm just saying that I'm just giving some ideas. You can work on that, you can refine it further. Okay, so the idea here is that this step itself, after this particular part, add if condition, where you are checking if the frequency is greater than n by 2. Okay, what is n? N is basically the length of the nums. Okay, if this is greater than n by 2, okay, that means you have got the real, I can say, the real dominant element. Okay, the dominant element as well as the frequency. Okay, so basically, yeah, that's what it is. So at least the most dominant element. You can continue this loop further. You need not break out of it. That's what I'm trying to say. You need not break out, but you can just continue. Now need the the dominant element, and obviously you can get this frequency also. So you don't need this part of. Okay, as simple as that. So what I'm doing is, I'm helping you skip a whole iteration over it. Okay, as simple as that, right? Now the other part, it's very simple. So what we're doing is, we're going through the index from 0 till n minus 2 index. Okay, why n minus 2? See, the idea here is, when you if you see what is happening, none of the halves should be empty. Okay, none of after you are splitting, both halves should have at least one element, right? So that is the basic idea. That's why I'm going from 0 till n minus 2 index. Okay, so what we are checking is, if the current number is a the current number that we are in, num sum I is basically is the most frequent element that we identified, that is the dominant element of the whole array. Then what we are doing is we are simply incrementing the frequency. Remember, this is the current frequency. Then I'm just checking what are these values. See, this value will tell us the current frequency is greater than I plus 1 divided by 2. This will tell us, see, the idea here is this thing is going to tell you like how many elements are there in total, okay, and what are the number of elements in total divided by 2, okay. So our current frequency should be greater than this particular value, okay. That is what is the definition of dominant, okay. Dominant means like it should be more than the more than half of the elements, okay, simple as that, right. That is the basic definition, more than half of the elements. So for the first half, this is going to be the formula. Like how this formula comes, you have to simply take few examples and try to understand how it works, okay. Because see here, index start from 0, so that's why I have to add a plus 1 here, okay, simple as that. And for the other half, it's very simple. What you have to do is take this value, most frequency element frequency, and from there you're subtracting the current frequency, okay. Here we're directly using current frequency, here you have to subtract this from the current frequency, and then n minus I minus 1 you have to do, okay. And then you have to divide by 2. Why I'm doing this? Again, the same reason. You have to just take an example, like see how much are the elements remaining, and then you have to decide how much. See why you have to add a minus 1 and why you don't have to add a minus 1. You have to understand that way, okay. You have to take the examples, you have to understand that. And then I'm divided by 2. If this particular value is smaller than this particular value, okay, then we can say that yeah, for the right term also this is being satisfied. And then we are returning the I, otherwise we are returning minus 1, okay. If this whole loop completes without being without the return being executed, then we have written minus 1. So this was the code. I've given you some more ideas. See, within a single loop, like this is a single loop, what you can do is within a single loop, you can get this thing done, okay. You don't have to do this part of the code, okay. So you are basically saving the whole iteration, okay. So yeah, that was all for this particular video. See, there are some algorithms because of which, see, even if you see the space and time complexity of this, it is O of n and O of n, okay. So there is some there are algorithms because of, with which you can get the dominant element without having a hash map or any data structure as such, okay. With a constant space you can get the dominant element. That's what they mentioned in the editorial, so you can go through it. But yeah, that's a pretty specific case, because see, here the definition of dominant is very clear, more than half, okay. Remember, this will the same concept may not work if, see, dominant doesn't mean like the element with the highest frequency. It's not like that. See, dominant means the one which has more, the frequency of which is more than half of the elements of the given summary, okay. So the difference is slightly different. It's not like the most frequent element, okay. Most frequent is a very generic definition, okay. But when we say it's like more than half of the elements present, it's very specific definition, okay. So both the cases are slightly different. Try to understand the difference and yeah, accordingly go for the solution. So you can learn that around. There is nothing hard in that. There's definitely a pretty simple one only. But yeah, it's worth only when this particular case comes. So yeah, that was all for this particular video. And if you like the approach, if you like the content, please subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.